Okay, welcome back. Yes, let's see how many of you are still here. I guess a bunch of you are still here. Good. Thank you so much. All right, let's do this. What am I doing here? Hold on. Here we go. Hold on a second. Let me go back here. Okay, and back here. Whoops. Okay. Okay, sorry, I was playing around with things. I probably should have just paused here for a moment, but we're back. Okay, so those of you who are here, what you want to do is you want to get yourself some materials. Now, here's the thing, though. I realize some of you might be working off of just an iPad or maybe an iPhone. And so I'm just going to walk you through the materials you need and what to do, and then maybe just sit around a little bit while you guys work through it. If you want to do it right now, you have till midnight to turn this in. And once more, if you can't do it by midnight, don't worry about it. You submit it later tomorrow, and it's be fine. Okay, I'm just giving you due dates and deadlines just to keep us on pace, just like like benchmarks. But again, I want to work with you and make sure that I want everybody to get to do these things more importantly than doing them like by a certain date and that kind of stuff. That's just to help you pace your study and stuff, okay? All right, so let me tell you what are some of the things that you need. So the first thing we need is we need the actual procedures. And let's see if we can find that. So let's look at our Canvas page again, if I can find it. Let's see if it's somewhere in here. Okay, here we go. Okay, so let's see. This is the assignment that we're talking about. It is called Experiment P11, Buffers and pH. And this is the activity. So if you have your Canvas available to you, you can open it here and see what it says. So basically what it's saying is we're going to do an online version, a virtual form of Experiment P11. If you don't have your lab manual, I posted in here the actual file. So you can either view it right here in Canvas, it's right here. Oops, you can see it there. Or you can download it and have it on your computer. Either way is fine. In terms of writing the stuff, again, this is a Word file. So if you have a way of opening, Word, either with Word or Google Docs or whatever it is, you should be able to simply fill in the values here. You can't do it right now because this is just showing a preview. But on the actual file, you can fill in the procedures here, okay? So let me walk you back. I'm gonna, because this is just too small here, I'm gonna go back to the actual document, just in case those of you who actually were able to download it. And it is, let's see what, oh, here it is, sorry. Here it is. Okay, so this is the actual document. Let me blow it up a little bit so it's better visible. So it starts off with giving you a review of what buffers are, right? And how it works with a weak acid and a base. For example, this one that you have here is another way of writing the formula for acetic acid, for example. And you can see the double arrow, and they've taken, the liberty of putting the reverse one bigger just to indicate that there's very little of the forward reaction that happens, we know, because the equilibrium constant has a very small value, right? So the idea is that when you have a mixture of both the acid and its conjugate base, this equilibrium generates a buffer system. So the procedure here, if you were in the real lab, is you would have made a solution of this buffer. It walks you here through some of the steps you would have taken. For example, you're going to make an HCl solution. That's going to be your challenge solution, all right? and it walks you through. And please go through it to get an idea more or less of what you're going to be building here, okay? For the buffer, you're going to be given a solution of sodium acetate, and you're going to be given a solution of acetic acid, and it tells you what proportions to mix them in. So you may want to go back and calculate. I mean, I could have asked you this as part of your post lab. Calculate what is the molarity of the acid and the base in this buffer system. But that was not the purpose of the lab, so we're going to leave it at that. But if you want to, you can go back and calculate that, right? So you're going to use your HCl they give you, is a 1 molar HCl to make a challenge solution of HCl. And then you're going to set up several beakers to put water in and buffer. And then you're going to set up a pH meter. So the pH meter that we use is not the one that looks like a big box with dials and bells and whistles. It's just like the shape and the size of a big marker. You hold it in your hand, you can leave it in your pocket, like a pocket size kind of thing. All right. And there's several things you have to do with that, and we have a video for that. And then what you'll do is you're going to set up essentially a series of testing beakers in which you're going to have, in one of them, you're going to have water, and the other one, you're going to have your buffer solution. And you're going to set up burettes so that you can add specific volumes, for example, in here, step 7 of the HCl solution. So you're going to add first 5, 10. Now, here's one of the things that sometimes confuses students when you look at the data sheet. There's 2 columns here. One says volume of HCl solution added, and then the total volume. So basically what it says is you're going to start with nothing in here, which means that this guy here would be 0, right? There's nothing added. And then you read the pH for the buffer and the pH for the water. Then you're going to add 5 milliliters, which means your total volume now is 0 plus 5, which would be 5, right? And of course, by the way, you probably want to keep a good record here of sig figs here, right? And then the next one, you're going to add 5 more. So you had 5, you added 5 more, so now you have 10, right? And so forth. Notice that this column you're building, where you track the total volume that's being added to your buffer or to your water, that's the column you're going to use to build your graph. Okay? Does everybody understand that? Any questions? All right, let's go back. So essentially what you're doing is, that's the format of the experiment. You have a beaker with water and a beaker with buffer solution. And into each one of them, you're going to drip, for one set of them, you're going to drip HCl solution, same amounts to each. And for the other set, you're going to be dripping NaOH solution, same amount to each set. And what you do is, for every addition, you check what is the pH meter reading. Okay? So that's the experiment. Now, the other thing I wanted you to do was basically to go and watch this video about how to use a pH meter. And I had it in here, but I had to switch it around. So come back here. And here is the, where did it go? Oh, there it is. So this is the video, and yeah, let's go ahead and see if we can watch it together. Oops, hold on a second. I may have forgotten to do something here. Hold on. Just a moment. I'm going to be sharing that video. I got to make sure the computer sound is working. All right. Okay, there we go. So let's go ahead and run this so you guys can follow along. If you have any issues, just do a hand raise icon in case the audio doesn't come through.
Hi, I'm Jared Hyman, an assistant professor of chemistry at Elon University. Today, we will be discussing the proper titration technique using the complete single burette assembly kit available from Carolina Biological Supply Company. This is the first in a 2-part video series on titration. The purpose of a titration is to quantitatively determine the concentration of an unknown solution, commonly called the titrand or analyte, by adding a volume of a chemical with a known concentration called the titrant. To mark the endpoint of a titration, an indicator is added to the analyte. Let's review some of the equipment that's needed for a titration. Carolina's complete burette assembly contains.
Oh my guys, I think that's the wrong video. Yep, this is not the right video. Hold on a second. Let me pause the recording here for a moment and let me look for the correct video. Okay, I had the wrong video in there. That's the video for doing titrations, which it goes in your next in your KSP experiment. Sorry about that. So let's go back here. Let's put this one in. And oops, sorry. I keep messing with this thing. And all right, here we go. Share, share. Here we go. Okay, this is the real one here. Here we go.
We're going to do a short review of how we use the new pH meter. That's this thing right here. This is a new handheld pH meter, really easy to use. All right, the first thing you're going to need is some CHEM wipes. That's these things right here. The solution that you're going to measure, in my case I have a 10% sodium bicarbonate solution. And then you can use either a small 50 ml beaker or a 100 ml beaker. And I also have a larger beaker. You don't have to use this, but I'm going to use this for a rinsing step because I don't have a sink right here. So the first thing we're going to do is we are going to remove the cap from the pH meter. This may take a little bit of strength, so pop this cap off. Be careful because there is a little bit of solution in this cap, and that's what protects our pH electrode, this little glass bulb here, when we're not using it. So this cap I'm going to either put into the 50 ml beaker or the 100 ml beaker, and that's going to help me keep from losing this thing. So once we set that aside, we're ready to go. We're going to turn on the pH meter by holding down the power button. It has a circle with a small line through it, which most power buttons usually have, and the word mode next to it. So we're going to hold that button down for a full second. There we go. Alright, so immediately you're going to see a pH reading. We're going to take the pH meter and you're going to put it into your solution, and that's going to give you your pH of the solution. Here we have a 9.27 reading for the pH, which is about right because sodium bicarbonate is slightly basic. So anytime that you're going to change solutions or put the pH meter back onto its cap, or its cap back onto the pH meter, we're going to have to rinse the electrode because we don't want to keep any of the things that are inside this solution here that you're measuring the pH of. We don't want any of that stuff to be stuck on the electrode because that's going to wear it down and make us not able to use it in the future. So we're going to rinse that. Here I have a larger beaker that I'm going to use to rinse the pH electrode with. So I'm going to hold the electrode over the larger beaker. You can hold it over your sink if you want to. And I'm going to use DI water that's at your table, and I'm going to rinse the electrode. You got to get in there really good and rinse all around, everywhere where you had that solution. Give it a nice shake. And I'm going to wipe around the electrode, make sure I get all that juicy stuff off, the outside there. And that little glass ball there, the actual electrode bulb there, we're going to just tap it very gently with this CHEM wipe. So after you've done that, you're ready to put your cap back on. Here I have the caps numbered, so if you see this cap is number 8, this pH meter is also number 8. When you're ready to put this back on, you're going to have to make sure that there's a buffer solution inside that cap in case we spilled any out when we were taking it off. That happens very easily. So what we're going to do is we're going to set our pH meter to the side, and we're going to take some pH 7 buffer. That's this right here. It's a pH 7 buffer solution. And we're going to pour some into a beaker, just a little bit. And after we've poured some into a beaker, we can take our plastic disposable pipette or dropper and we can suck some up. And inside this cap, there's a small cylinder or circle. We're going to pipette the solution down in there. You may or may not be able to see that, but when you're doing this, look in there, you'll see it. And once you've done that, once that solution's in there, we're ready to put the pH meter back in there. So we're going to hold the power button for 1 full second again till it says off. There we go. So once it's turned off, you can now put the cap back on. You can do this by leaving the cap inside the beaker that you had it in and pushing down to snap it on, or you can do it with your hand. You know which way the cap's going to go on by looking at the numbers. So the numbers should both be on the same side. That's how you're going to know which way the cap goes on. Okay, so basically that's how you're going to use this instrument. If you have any questions about calibration of this piece of equipment, then you will have to talk to your instructor.
Actually, what you will do is you can watch the other video that I have in there that walks you through how you would calibrate a pH meter. But normally in lab, we don't have you guys calibrate. We basically give you the pre-calibrated pH meters, and all you do is do the experiment. All right, so let's go back to our procedures here again. Where were we? Where are we? Forget which of these things it is. Oh, here we go. Sorry about that. All right. So again, if you read through here, you'll realize the way the experiment is done. And again, remember that what you are doing is you're adding successive amounts of first HCl to the buffer, HCl to the water. You can do them, you know, same at a time, or you can basically do the buffer first. Now, normally, you're going to be having only one pH meter. So you want the pH meter submerged, let's say, for example, in your buffer solution. And you add your HCl, you let it stir, and then you record the buffer, the pH reading, et cetera, et cetera. Now, don't forget that you want to keep a running track of the total amount of acid you've added at each point. So like I said, if you add 5 milliliters, that's 5 milliliters more is 10. When you add 10 more, that's going to be 20, and so forth and so forth. And this is the column that you're going to be using to build your graph. Okay, so you essentially are taking 4 sets of data. You're taking the pH measurements of buffer against HCl, water against HCl, buffer against NaOH, water against NaOH. So those are the 4 sets of data that you would have collected. All right. Now, what I did here was I put in the in our PowerPoint thingy here. Sorry, let me get this out of here. Goes back into Canvas. Okay, so like I said, if you want to see how calibration is done, the second video here, that's the one. And then what I did is I gave you a set of data, all right? And once more, I don't really mind how you do this. You can simply copy this, or you can print it. I I realize that the different students have different accesses to different technologies. I don't want for it to be a stress factor to figure out, okay, how do I do this? How do I do that? Guys, if all you can do is basically copy this down on a piece of paper, that's fine with me. All right, it's fine with me. So what will happen now is you have to use this data to generate graphs. So I'm giving you this data. Everybody got the same data. This is not like one of those, you get unknown 1, unknown 2. No, there's only one set of data for everybody. If we had done this in the lab, essentially, we only have about 4 working pH meters. So you would have been working in groups of 8 or 10 anyway. So it really doesn't make a big difference. So please watch the data here. As you add HCl to the buffer, as you add HCl to the water, all right? And then as you add NaOH to the buffer, as you add NaOH to the water. And the goal is to build 2 graphs that illustrate how the buffer resists the change in pH, okay? So what you'll do basically is, in this data set, I don't have here the total running volumes. We'll have to fill that in later on. This is just basically the volumes added, but in your actual table, you had to fill in, what is the total running amount of buffer. Okay, don't forget that. Again, you are recording not the amount of HCl that was added at each step, but the running total through the whole sequence of steps, okay? All right, everybody understand that? All right, cool. So, so how do we use this data to do a graph? So I actually have an Excel spreadsheet here where I can do this thing. Let's see if I can find it. Okay, so here. So what I did here was, this is a set of data, and I'm not exactly sure this is the same one that I have in there that I gave you. It may or may not be. So notice that I had to insert an extra column here. You notice it, right? Oops, sorry, wrong one. Notice that I added an extra column in here where I'm tracking the running total volume of HCl, right? That is the one that I need for making my graph. And then over here, I have the pH of the buffer solution and the pH of the non-buffer solution. Now, this is very important. You have to put both of these on the same graph. So remember that the way you do it is you select your data. So we're going to select the column that has the total running volume of HCl, the pH of the buffer, and the pH of the non-buffer, which is just the water. All right? And then you're going to go to Insert. And you want to do, I put a comment down here, a graph setup. Select the 3 columns. You might want to write this down, later. I'll leave it, I'll let it sit here for a little while so you can see it. Select the 3 columns. That's what I did. Insert graph. Use scatter with smooth lines and markers design. So let's find that guy here. I think it's in here. And here it is. This is the smooth lines and markers. Bang. So there's my graph. I'm going to roll it down a little bit here so we can put it next to the steps that we're going to take next. All right. Oops, sorry, my bad. Let me grab the whole graph. Bring it down here. Okay, I'm going to blow it up a little bit so you can see it a little better. Okay. So right now, the graph is pretty plain. It's giving me the, legend down here. Notice I do have the 2 sets of, I can already see that one of them starts out pretty flat, whereas the other one drops dramatically. And by now you should know which one is which, but you'll have to label them afterwards, okay? Remember one thing, if you print this to like a hard copy, like a black and white printer, nobody can tell the difference between these 2 things. So you may want to change the markers on one of them later on, but most of you will more likely print this to a PDF, and so it'll come out in color and it should be fine. Okay, so my next step will be, it says here, add chart elements to add axis titles. Or where do I do that? Well, remember that in these modern Excel things, there's a little plus sign here, and that's the one where you use to add things. So it says here access titles. So let's put access titles in here. All right. Now, to make it a little more understandable, we want to put a chart title here. Oops, what happened here? So let's edit the chart title. I'll let you guys do whatever you want. pH changes of buffer versus non-buffer solutions to added HCl. That's kind of like very long, but hey, that's fine. All right. And of course, I want to edit these titles here. So this one here would be the milliliters of HCl. By the way, I don't like the way this is here. Right? I need a decimal in here. So I'm going to format these guys here to give me 1 decimal. And that'll fix the graph here a little bit. Actually, probably should be 2 decimals, but that's fine. Okay, so milliliters of, actually, I think we're adding 0.1 molar HCl. I think that's what it was. You got to check it later on. And then I'm going to change this one here. So this one's kind of a little hard to change here. So probably I'm going to do it up here. So this will be the pH of solution. There we go. All right. So the other thing I want to do is, I don't know about you guys, but I mean, right now it's fine. This is pretty good. I would like to maybe change the markers. If I'm going to print this to a black and white printer, I might want to change the markers on these. And I think the way you do that is you click on the graph itself here, and then you can edit the format here. I forget where you do that. Anyway, you can change the markers from circles into X's or I don't know, little check marks or whatever. The last thing is pH of buffer solution, pH of non-buffer solution. I'm going to do a few things here. First of all, I am going to come here in this plus thing here, and where it says legend, I'm going to click the little arrow here, and I'm going to basically, I want to put the legend on the right, right? And then what I'm going to do is I'm going to come in here and I'm going to, let's see, I'm going to look here at the, I'm going to right click here on this series. And like it says here, I'm going to do select data. So right now, this box shows me what is the data range that I have here, right, for my graph. And you can see the blinking, the scrolling broken lines here surrounding the data. But right now, it tells me here what each one of these is. So I'm going to shorten this. Now, you don't have to do this if you don't want to. I just want to shorten it here. So if I want to change what the legend says, again, remember what I did was I went here, I right-clicked on the data set. I did select data, and I'm going to go here and I'm going to put edit. I'm not going to change the values here. I'm just going to change the series name. I'm going to call this guy, I'm going to call it buffered. And then I'm going to go to the other one. I'm going to edit it, and I'm going to call it non-buffered. And I'm going to click OK. And there we are. That's a graph. All right. Again, I don't know if this is the same data that you have in there. I might have just done the graph for you. So again, if you want to spread it out a little more, just open the box here. And remember, you need to have 2 of these sets of data. I mean, 2 of these graphs. When you are ready to print, again, you want to click, if you simply go like this, like right now I'm here, sitting here, I'm going to go File, and I'm going to go Print, and it's going to try to print the whole thing. And it's only going to spread it over several pages, which is really not helpful to me. So what I want to do is I want to bring my clicker over the graph, select the graph, and now go File, Print, and now it's going to print just the graph for me. And that's what I need for my lab report. Okay, what printer? Well, again, many of you might not have a printer at home, but if you have Excel, you have this Microsoft Print to PDF that's kind of built in. And that's probably the one you want to do, because then it'll print your graph to a PDF file. Okay, let me give you some of the possible situations here. Number one, I don't have Excel. Well, remember that as an LBC student, you have the ability to download the whole Office 365 suite. You don't even have to download it. You can set up an account online and do it all online. So you have access to Excel online. You don't have to even download it to your computer, all right? If you choose to do a different graphing program, which is perfectly fine, again, whatever you do, make sure you print just the graphs. And remember, there's another graph for the NaOH challenge set, all right? Don't forget that. Let's say that right now you don't have any of these tools. You know what? If all you can do is hand draw a graph on a piece of paper, you know what, guys? That's fine. If that's all you can do right now, you don't have Excel, your computer cannot access it, your iPhone cannot do it, guys, just do it on a piece of paper, all right? Now, here's the thing. Don't be sloppy, okay? It's okay to, not be artistic and not be perfect. That's fine, but don't be sloppy, okay? If you're gonna do a graph by hand, use a straight edge to draw the axis, okay? And keep everything in proportion. And when you draw the lines, remember, it's not connect the dots, right? It's a smooth line joining the data as best as you can, all right? So that would be fine, all right? That would be fine. All right? So that's basically kind of the way it works. So let me now see if you guys have any questions. Either unmute your microphone and ask, or put it on your chat here. Let me see on the chat. Somebody was asking about, do we have to print? Yes, you can upload the graph. You can print it to PDF. You can upload it as a PDF. Again, as long as you have the Office 365, it comes with a built-in PDF driver. So you should be able to convert everything to PDF. If not, there's another option that you have, which is the following. Let me see if I can go here to Google. You can Google this thing called Cutepdf Writer. Here it is, Cutepdf Writer. And this is a product that is a free download. And you can download it right here on this page, Cutepdf. It's very simple. It's not gonna let you kind of like manage or join, PDF files and stuff like that. But if all you want to do is be able to print things to PDF, this is my favorite. This is the one that I used for many years before Microsoft came up with bundling in their PDF printer inside their suite. So you can do that also, okay? And I think if you go to our, if you go back here, where was I? Here. If you go back to our assignment here, I believe that I put that in here as a link. Oh, here it is. There's a link here for that Cutepdf thing, all right? Okay, so again, make sure you read through here. Remember, you have two graphs, addition of HCl to water versus buffer, addition of NaOH to water versus buffer, all right? Make sure you put a title, make sure you label the graph axis, all right? Again, I kind of like over formatted a little bit to make it look more like the way I like it to look. But you don't have to do all those things. As long as you have properly labeled access and a title, and it is easy to tell which line represents the buffer, which one represents the water. That's fine. Be aware that on that data file that you downloaded or you previewed here, and again, you can simply you can submit this with your lab report. Just realize that when you do your Excel chart, you're gonna have to add in there. In other words, this is an incomplete data set. Okay, remember that in the actual file or in the actual lab manual, oops, there is that extra column where you had to total the volume of HCl added after each step, right? So you have to have a running total of volumes of HCl. And I just showed an example a little while ago how to do that. Okay, don't forget that has to be in there in your data sheet that you submit, all right? So notice that there is a second page to this that has some questions. Oops. These are some post-lab questions. Once more, you can either, download the file and write them right in there in that space in there. It shouldn't take more than a couple of lines to answer each one of these questions. All right. I don't need an essay. I don't need a scientific paper. I just need a couple of sentences to explain what you observe. All right. If you can't do that, just write them on a piece of paper by hand and then, send a picture in here. All right. All right. And then basically here is the summary. Like it says here, you may handwrite your answers and then scan them, or you may edit the file directly. Please, if you edit the file, when you upload it, make sure you give it a different name. Maybe use your name, Experiment 11, something like that. Just in case I lose track of them and I had to download them, I want to make sure that the file I'm downloading is yours and not a generically named file. Okay, so your assignment consists of the data sheet file, the one that I gave you, your graph, right? And then your post-lab answers. So up here, you'll have the submit assignment, and it'll open up to something that has the, like where you can either, upload your files in here and then submit the assignment, all right? So that's pretty much the activity. So let me see if there are any questions. Okay, couple questions here. As a day, do we need to show the equivalence point? The answer is no, because this is not a titration. This is just simply seeing what happens to a solution when you add acid or base. There's no titration going on here, okay? So no need to do equivalent point. Denise, specifically, what do you mean about the post-lab question? Can I talk about the post-lab question? What do you mean by that? I'm sorry. You can use your phone if you want, your microphone if you want.
Oh, like, how do we, like, when it says like observe, like for the first question, like it asks like how do we observe, like how do we answer it since we weren't there to do the actual lab?
Well, what you have is the graph, right?
Oh, okay.
So you look at the graph, and what does the graph tell you about what's going on? It's basically.
Okay.
Okay?
Okay,
Cool.
thank you.
Cool. Any other questions? Cool. Yeah, it got dark kind of fast in here. Okay.
So I have a question. Hi,
Yes,
everybody. For the question 2, when you said which one is blocking for adding the HCl, or then for question 4, is H plus in question 2 and OH for question 4?
Oh, hold on a second. I'm not sure I follow you. Let me.
Said which chemical in the buffer solution is responsible for blocking the acid activity of the HCl?
Okay, hold on. Let me go there for a moment. Oh, here we go. I couldn't find my. All right. So here's what you have. Okay. So what do you understand by blocking the acid activity of the HCl? What do you mean by? What do you think it means?
When we have a weak acid in our, or weak base in this case, in our buffer, which that can block the strong acid,
Okay.
right?
So the buffer is made of two chemicals, right? What are the two chemicals in the buffer?
It's a weak acid and weak base.
Okay, so the question is, which of those two is responsible for kind of like absorbing the
Weak base?
HCl?
It's a weak base. But should
Okay.
we say weak
So
base or should we say OH?
No, you want to say what it is. This is a specific buffer. This is not a generic buffer, right?
Okay.
This is a acetic acid acetate buffer. So you want to show, okay, who of the two components is the one that is, taking care of the extra acid, and then write a chemical equation.
Okay.
All right, cool.
Thank
That's
you.
a good question. Yeah, I wasn't sure exactly it was going to come across this idea of blocking the acid or blocking the acid. I'm not exactly sure if I should have used a different word, but hopefully you guys get the idea here, right? All right. Let me know if there's any other questions. All right. So I'm not exactly sure if some of you are able to work on the activity while you have the Zoom in here. I'm not exactly sure how it works, but let me give you a few minutes to maybe look through it again. See if you guys want to start doing your graph and stuff. See if you run into any problems. I'll sit around here waiting for a little bit. I am going to unmute I'm going to mute my phone though for a moment here, just in case I cough or sneeze or something like that. I won't distract you. But go ahead and see how much you can do, and if you run into any problems. Remember, you have until midnight to turn this in, so you don't have to do it right now. This session is being recorded also, so it'll be posted. So if you need to wait a little bit and turn it in tomorrow, that's fine. If you want to wait until the recording is in there in case you missed anything. All right. So let me know if there's any questions. Okay. I'm so glad you guys are here. That's awesome. Yes, I said it.
Are we going to have a recording for tonight? Because I just want to make sure the title. Sorry.
Is it going to be ready by tonight?
Yeah, when that would be available, the recording.
Okay, so I can get this one available by tonight as soon as we finish here. The one for the lecture might take until tomorrow morning though.
No, just for the graph. Just for the graph, I need some help. I can just watch again. Just for the graph part.
Sounds good. Let me take you back there anyway. Okay, so what I did here was I looked up in the help guide how to do the double graph, and I wrote the instructions in here. I mean, if you guys want, you can just, I guess if you're on the computer, you can take a picture with your phone, but if you're on the phone, you can take a screenshot, can't you? I can maybe blow this up.
Take a picture.
Let me blow this up a little bit.
I just took a picture. Thank you, Professor.
Yeah, that'll work. Or you can take a screenshot. I kind of blew it up a little bit so you guys can see it. I mean, it's just basically, I know that we don't, like if you're like me, you don't do graphs all the time. So sometimes I forget how to do certain things. So what I do is I look it up and I write it in there so I have it as a reference. I obviously didn't write in here, edit chart title. You know what, I'm gonna add in here, edit chart title and axis titles. There you go. There we go. I had forgotten to write that down.
So I have one last question. I'm sorry.
Go ahead. Is it about the graph?
No. We can record the lecture or any Zoom meeting in our own computer, but you need to give us the permission.
Yeah, we are not allowed to let you record them on your own.
Okay, thank you.
That's kind of like more of a mandate from the university.
Okay. Thank you so
So you
much.
do have to wait for mine. Okay. Oh, sorry. I kind of scroll out of the way here. Okay, some of you are still looking at this. Is anybody trying to do the graph right now or running into any problems with it? Let me know. I'm going to play around with this a little bit. I want to see how to change the little ticks here. Let me see, format data series. No, that's not it. There. Sorry, I'm trying to get. Trying to figure out how to change the shapes of these markers here. Nope. That's not it. Let me look in here. Change markers. What? This is crazy. Oh well, anyway, I can't seem to figure out how to change the shapes on those things. We'll figure it out later on. Oh, I put you back here. Okay. Okay, anybody else? All right, we'll sit around here for a little while longer. Give you guys a chance to work on it, and as you work on it, let me know if you have any questions. All right, so I'm gonna basically stop the recording here. Oh, somebody asked how to change the digits. So question was, how did we change the digits? Remember, anytime you want to change formats, you basically select whatever you want, right click, and then look for the format cells command here. And that gives you a whole set of possibilities here, for example, for numbers. If you want it percentage, if you want it as a currency. So for numbers, basically, that's where you choose how many decimals you want. So if you want like 2 decimals, you can just click to 2 and then click OK. And the graph will generate those same things in there. In this particular example, I'm not sure that's a huge thing. Because like I said, we're not doing a titration. We're looking for specific molarities and stuff like that. We're just kind of like generally qualitatively tracking what is the pH change that is happening. And the main observation is that one of these guys starts out rather flat with very little change, and the other one rapidly changes in pH. Of course, the one for the base will have the opposite direction because it goes from near neutral to high pHs, right? All right. So I'm going to stop the recording here, and I will have that posted later when we close the meeting. All right. So